Hello and welcome. In this video tutorial, I want to go over how to simplify radical expressions. Now, the idea here is that sometimes you have numbers underneath the radical which are not perfect squares. For example, the square root of 16, that would equal 4. And then the square root of 100, that would equal 10. But then there are numbers like 108 and 84 where there doesn't exist such an integer that when you multiply it by itself, it'll give you that number. Just because it's not a perfect square doesn't mean that we cannot simplify it. Sometimes we can. So let's explore this idea with example number 1. Let's simplify the square root of 108. To simplify this, we'll begin by getting the prime factorization. And to begin the prime factorization, I need to find a pair of numbers that when you multiply them together, they'll give you 108. I've already brainstormed a few possibilities. So I know that 2 times 54 is 108. 12 times 9 gives us 108, and then 4 times 27 also gives us 108. Maybe there's more, but these are the ones that I brainstormed. Now, I also want to note that the combination that you do not want to use is 1 times 108, because remember that we want to simplify this. And if this is the only thing that you can get, then that's telling you that your radical cannot be simplified. But we're not in this case since I've already shown you that there's many possibilities. Now you just choose one of them, and I'll choose this one. It doesn't matter which one you choose because you'll get the same result after you've simplified, whether you use this or this. So here I have 2 times 54. Next, I'll begin to circle the prime numbers. Here the 2 is prime since the only numbers that divide it are 1 and itself. I'm going to circle this, and I'll repeat the process with the 54. I need to find a pair of numbers that when you multiply them, that will give you 54. And here, I know that 6 and 9 get the job done. I scan the 6, I scan the 9, and I know that none of these are prime. I can still simplify them further. So the 6, I can break it down as a 2 times 3. And the 9, I can break that down into 3 times 3. And here, now I have all primes. Now that I have the prime factorization, I can rewrite the square root of 108 as the square root of, and because I'm taking the square root, I want to get pairs. So here I have a pair of 2's, and I'll rewrite these as 2 squared. I also have a pair of 3's, so I can rewrite those as 3 squared. And I have this 3 remaining. I can't pair this up with anything, so I'll simply write it as 3 by itself. Because I have a monomial inside of the radical, basically I'm not adding or subtracting anything, I can distribute the radical to each term here. So I can rewrite this as the square root of 2 squared times the square root of 3 squared times the square root of 3. And recall that the square and the square root cancel out, so these two things are going to cancel out, leaving me with a 2 times the 3, radical 3. And we can see that the simplification of radical 108 is 2 times 3, which is 6, and then radical 3. Let's look at example number 2, simplify the square root of 84. I'll begin by getting the prime factorization of 84, so I need to find a pair of numbers that when you multiply them together, they'll give you 84. Here I'll use 2 times 42, and I can immediately circle the 2 since 2 is prime. 42, I can break that down into a 7 times a 6. The 7 is also prime, and the 6, I can simplify that as 2 times 3. And now I have the prime factorization. I can rewrite the square root of 84 as the square root, and here I want to get pairs. So here I have the 2, I have a pair of 2's. I can rewrite those as 2 squared, and then the 7 and the 3, I can't pair them up with anything else, so I'll write them as 3 times 7. And now I can distribute the radical to each individual term, leaving me with a square root of 2 squared times the square root of 3 times the square root of 7. The square and the square root are going to cancel out, leaving me with a 2. And then these ones, I'll just combine them together. So 3 times the 7 is 21. So the square root of 84 simplifies into 2 square root of 21. Let's continue to practice with example number 3, simplifying the square root of 72. So I'll begin by getting the prime factorization. And the 72 I can get by multiplying 8 and 9. The 8, I can break it down into a 2 times a 4. And the 9, I can break that down into a 3 times 3. The 2 is prime, the 3's are prime. And then the 4, I can simplify into 2 times 2. And now I have all of the prime numbers here. I can rewrite the square root of 72 as the square root. And here I'll get the pairs. I have a pair of 2's, so I can write it as 2 squared. I have one single 2 there, and I have a pair of 3's, which I'll write as 3 squared. Now I can distribute the radical to each individual term, giving me the square root of 2 squared times the square root of 2 times the square root of 3 squared. The square and the square root are going to cancel out. Leaving me with a 2 times radical 2 times a 3. And I can combine like terms, so 2 times 3 gives me 6, and I have a radical 2. So that's the simplification for the square root of 72. Let's go over a few more examples. Here for problem number 4, we have the square root of 48. So to simplify this, I'll begin by getting its prime factorization. And I can do this by getting the 6 and the 8, since 6 times 8 multiplied to 48. I can simplify the 6 into a 2 times 3. And I can simplify the 8 as a 2 times 4. I'll circle all of the prime numbers. And then I'll simplify the 4 into a 2 times 2. Now I have all of the prime numbers. I'll be able to rewrite the square root of 48 as the square root, and then I'll get the pairs. So here I have a pair of 2's. I'll write that as 2 squared. I have another pair of 2's. So I have another 2 squared. And then I have 1, 3. I'll write that right here at the end. I'll now distribute the radical to each individual term. So I get square root of 2 squared times square root of 2 squared times the square root of 3. The square and the square root are going to cancel out. So I have a 2 times 2 times radical 3, leaving me with a 4 radical 3. And that would be the simplification of the square root of 48. Let's do one more example. Example number 5, the square root of 196. So I'll begin by getting the prime factorization of 196. And here I'm going to use 4 and 49. 4 times 49 will give me the 196. The 4, I can simplify it as a 2 times 2. And I already have a pair of prime numbers here. And then the 49, I can simplify that as 7 times 7. And I have another pair of prime numbers. Now here notice that I have a pair of 7's and I have a pair of 2's. So this is going to simplify to 2 times 7, which is going to give me 14. So that would be the square root of 196. In this example, it turned out that 196 was a perfect square.